I'm going to go over the solution for our linear regression assignment for this past week. And in this particular case, we had the S&P 500, which is our independent variable, and we have a stock XYZ as my dependent variable. And the reason why my XYZ is a dependent variable from the standpoint that when you kind of look at the stock market, and you'll get this when you get into Finance 331, but when you look at the stock market in general, in other words, if the market, in this case, when I refer to the market, I'm making reference to the S&P 500, or it could be the Dow Jones, but I believe everybody's familiar with the S&P 500 and the Dow Jones. So that is what we mean by a market. So in regard to the S&P 500 as the independent variable, as opposed to stock XYZ, one would assume that if the market, the S&P 500, goes up, the majority of stocks would go along. Or if the market, say S&P 500, is declining, we would assume that on average stocks would decline. So that's what I'm making reference to here. I'm saying stock XYZ is really dependent upon the behavior of the market. In this particular situation, I'm saying market is the S&P 500. So from that standpoint, looking at the relationship, I'm saying, can I come up with a mathematical model that I can use to forecast the price of XYZ based upon the market? And that's one of the reasons why we use regression analysis. In this case, we're using linear, simple, just due to the fact, once again, simple simply means I'm only dealing with one independent variable or predictor variable. Keep in mind that predictor variable, independent variable are one and the same thing. So that's what my underlying, you might say, objective is. Is there a mathematical model that I can use to forecast the price of XYZ? So to do that, we will go through what we normally go through. We'll look at data. We'll take our data analysis, and we'll come back here to regression. And we'll say, okay, we have to go forth and look at the Y range. And of course, the Y range is our stock, right? That's my dependent variable. And then I will look at the range for my independent variable. And make sure we always use those labels. And then, of course, we'd come over here and we would say, okay. And we'd come up with our results. And our results is really the nitty-gritty, and this will tell us if the mathematical model, once again, it's a linear regression, i.e. straight line. It's a plus bx. Y is equal to a plus bx. Or in this particular situation, it would be stock XYZ is my Y, dependent variable, is equal to the Y-intercept, in this case 0.16, plus the slope, and that's we'll say 33, right? Slope, highlighted in yellow, times the S&P 500. So let me just kind of once again I know in a previous video I've already I've gone over the regression approach, but let's just kind of look at the summary output. As indicated in the summary output, there are three areas: the regression stats, the analysis of variance, and then of course is looking at the individual coefficients. So here we have an R-square of almost 96% R-square coefficient of determination. As indicated in one of my previous videos, this simply means that with an R-square of 96%, I can explain. In other words, if you go back over here to our data, if you look at what's going on here, the difference as a percent, 0.95%, 0.66%, the reason why these percentages change over the past, I believe I used 20 periods. The reason why these values changed can be explained away with the S&P 500. In other words, I could say it this way: 95% of the behavior, the changes here, can be explained when I use these values for my S&P 500. So that is a very, very strong relationship. Coefficient of determination 95, we'll say 96%. That means I can explain, or only, we'll say 5% or 4% is not being explained, is unexplained. So that's a very, very strong measurement of the relationship. So when I come down here, really, in regression analysis, I want to statistically prove that there is a strong relationship between my independent and my dependent variable. We already know it's strong, right? 95.5, 96%. But I have to look at it. My focus now is on the relationship and how we go about doing that to measure, you might say, the strength of the relationship. If there is a strong relationship, is to focus in on the slope of the line. Think of it from this standpoint. If we go back to hypothesis testing, in other words, in this particular situation, in other words, the null hypothesis would be is that there is no slope. There's no relationship between, in this case, the S&P 500 and stock XYZ. The alternative hypothesis would be yes, there is a slope, or yes, there is a relationship between the S&P 500 and my stock XYZ. My level of significance would be 1% or 5%, depending upon the situation. And of course, I would say reject the null hypothesis if the p-value happens to be less than my level of significance at 1% or 5%. So in this particular situation, I'm focusing in on the p-value. The p-value here for the slope. And the slope is 1.33. It is not the y-intercept. It's the slope. I'm trying to see if there is a relationship. If I statistically speaking can prove that there is a slope, right, that 1.33, that slope is significant, then I have a strong relationship. So in this particular case, I have 1.173 to the negative 13. That simply means move the decimal point over 13 places to the left. And if I do that, yes, my p-value is extremely small, and it is less than my alpha or my level of significance. So therefore, I can say that yes, there is a relationship between dependent and independent. This mathematical equation for a straight line, which I've identified here, and this is really what I wanted you to write out: stock XYZ is equal to the intercept plus slope times the S&P 500. So I can use this equation to forecast the performance of XYZ based upon changes in the S&P 500. So that would be from the standpoint if I would go back and say, oh, the S&P goes up, we'll say 0.5%, 0.25%, I would solve the equation. In this case, say S&P goes up, as I mentioned, 0.5, 1.33 times 0.5 plus my intercept would give me what I anticipate, what I forecast in my stock XYZ should do.